Davis Alex from Namgongo Secondary and Vocational School. I am a teacher of mathematics, and today we shall be looking at a senior 2 topic called indices. So before we can look at this topic, we need to know the objectives, what must be achieved by the end of this lesson. So by the end of this lesson, I expect all my learners to state the laws of indices. Then I also expect them to apply the laws of indices in solving mathematical problems related to indices. So when we are looking at indices, we basically look at expressions. For example, when we have an expression like 3 times 3 times 3 times 3, this expression can be written in short form as 3 raised to the power of 4. So you count the number of times 3 has been multiplied by itself. And when you look at this expression, 3 has been multiplied by itself 4 times. So that's why it's written in indexed form or power form as 3 raised to the power of 4. And when we are reading it, it is read as 3 raised to the power of 4. So when you are reading this expression here, when you are reading this, it is read as 3 raised to the power of 4. The power is also called an index, and in this case, 4 is the power. 4 is the power, or index. Then the 3 is the base. The 3 is the base. So if we look at an expression which is 3 times 3 times 3 times 3, in power form can be written as 3 raised to the power of 4, where 4 is the power or the index, then 3 is the base. So we can define an index as the number of times the base is multiplied by itself. So an index is the number of times the base is multiplied by itself. So when you look at this expression, 4, this 3 here, has been multiplied by itself 4 times. So therefore, 4 becomes the power, or 4 becomes the index, because 3 has been multiplied by itself 4 times. That's why we define an index as the number of times the base has been multiplied by itself. So therefore, 4 is the power or index, and 3 is the base. We can also have other expressions. We can also have other expressions like 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. From here you can count the number of times 2 has been multiplied by itself. And if we have to count 1, 2, 3, 4, 5, meaning that 2 has been multiplied by itself 5 times. So the number of times 2 has been multiplied by itself is what we call the power. And in index form, this one is written as 2 raised to the power of 5, where 2 is the base and 5 is the power. We can also have another expression. Which is 5 times 5 times 5 times 5. This expression can also be written in the power form or index form. So when you look at this expression, 5 has been multiplied by itself 4 times. So in this case, it is written as 5 raised to the power of 4, where 5 is the base and 4 is the power. We can also have another expression which is A multiplied by A, 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 multiplied by A. So you can count the number of times A has been multiplied by itself. And if you have to count 1, 2, 3, 4, 5, 6, 7. So A has been multiplied by itself 70 times. So therefore, in index form, this becomes A raised to the power of 7. So A becomes the base and 7 becomes the power. Having looked at that now, we are going to look at the first two laws of indices. We are going to look at the first two laws of indices. Let me hope you are following and understanding. So when we are looking at the laws of indices, when numbers with the same base are multiplied or divided, their indices are operated according to certain rules. And we shall look at what we call we shall look at multiplication. What happens when you are multiplying numbers with the same base? What happens when you are multiplying numbers with the same base? So when you are multiplying numbers with the same base, for example, if we have a raised to the power of 2 times a raised to the power of 3, this can be written as a raised to the power of 2 multiplied by a raised to the power of 3. So a raised to the power of 2 can be written as a times a multiplied by a raised to the power of 3 can be written as a multiplied by a multiplied by a. Then from here, you can count the number of times a has been multiplied by itself. And if we have to count the number of times a has been multiplied by itself, 1, 2, 3, 4, 5. So a has been multiplied by itself 5 times. And that can be written as a raised to the power of 5. Also, we can have a raised to the power of 3 times a raised to the power of 4. So when we expand it, a raised to the power of 3 can be written as a times a times a multiplied by a raised to the power of 4 can be written as a times a times a times a. Then from here, you are going to count the number of times a has been multiplied by itself. So if we have to count a has been multiplied by itself, we are going to count the number of times 1, 2, 3, 4, 5, 6, 7. So realize that a has been multiplied by itself 7 times, and that can be written as a raised to the power of 7, where a is the base and 7 is the power. That's why we define an index as the number of times the base has been multiplied by itself. Now from here, there is something that we can observe, that when we are multiplying numbers with the same base, what happens to the powers? So what we are going to do, that will take us now to our law, our first law of indices. That when you are multiplying numbers with the same base, what you simply do? So what you simply do here is to add the powers. For example, I have a raised to the power of 2 times a raised to the power of 3. So here I'm multiplying two numbers with the same base. So what I'm going to do is to simply add the powers. And I say a raised to the power of 2 plus 3. And now when I add 2 plus 3 gives us the answer as a raised to the power of 5. The answer which we got in the previous case. Also we can have a raised to the power of 3 times a raised to the power of 4. So we are multiplying two numbers with the same base. What do? We are going to add the powers. And when we add the powers, we shall have it as a raised to the power of 3 plus 4. And we shall get our answer as a raised to the power of 7. Let me hope you have understood what I am doing. So generally, this takes us to our first law of indices. Takes us to our first law of indices, that when we are multiplying two numbers with the same base, we simply add the power. So when I have a raised to the power of m times a raised to the power of n, this is the same as saying a raised to the power of m plus n. So this takes us to our first law of indices. That when you are multiplying two numbers with the same base, what you simply do is to add the powers. We can now look at an example. So we are going to look at an example where we have our example. This is simplify. Simplify A. We have 4 raised to the power of 2 times 4 raised to the power of 3. Then we can have 5 raised to the power of 4 times 5 raised to the power of 2 times 5 raised to the power of 3. So what we are going to do here, if we work out part A, solution. Part A, we have 4 raised to the power of 2 times 4 raised to the power of 3. So what we are going to do here, since we are multiplying two numbers with the same base, so what we do is to add the powers. And we shall have it as 4 raised to the power of 2 plus 3. And when we add 2 plus 3, we shall have our answer as 4 raised to the power of 5. And we are going to leave our answer in power form. We are going to leave our answer in power form. Then when we look at part B we have 5 raised to the power of 4 times 5 raised to the power of 2 times 5 raised to the power of 3. We are also multiplying numbers with the same base. What do? We add the powers, which becomes 5 raised to the power of 4 plus 2 plus 3. And when we add this, what do we get? So we are going to add 4 plus 2 is 6, 6 plus 3 is 9. And shall have our answer as 5 raised to the power of 9. We leave our answer in power form. So that is all about our first law of indices, that when you are multiplying numbers with the same base, what you simply do is to add the powers. So we are going to look at our second law of indices. And now when we look at our second law of indices, this is now division. What happens when we are dividing numbers with the same base? We're going to start with an expression which is a raised to the power of 5 being divided by a raised to the power of 3. So now a raised to the power of 5 can be written as a times a times a times a times a, being divided by a times a times a. Then from here we are going to divide. Without cancelling out the common terms, we are going to divide. So this a can be divided by this a can be divided by this a can be divided by that a. And we remain with the a multiplied by n. And this in power form can be written as a raised to the power of 2, which can also be written as a squared. Then we can have another expression. This will take us to our second law of indices. Also, if we have a raised to the power of 7 being divided by a raised to the power of 7 being divided by a raised to the power of what? Of 2. So from here, a raised to the power of 7 being divided by a raised to the power of 2. A raised to the power of 7 can be written as a multiplied by 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 a. 7 times. You can even count 1, 2, 3, 4, 5, 6 multiplied by a. Being divided by a multiplied by what? By a. Then from here, you can now divide this a cancels out with this. This a cancels out with this. Then we remain with, in the numerator, we have remained with 5a, that is a raised a multiplied by a raised multiplied by a, which is a multiplied by a multiplied by a. So in power form, how do we write this in power form? So in power form, this can be written as a raised to the power, you can count 1, 2, 3, 4, 5. A raised to the power of 5. A raised to the power of 5. powers. That's what they said. The index of a quotient is the index of the divisor subtracted from the index of the dividend. That the index of a quotient is the index of the divisor subtracted from the index of the dividend. And that will take us to, if I have, to take us to this example here. Learners, let me hope you are understanding or you have understood what I am doing. So if I have a raised to the power of 5 being divided by a raised to the power of 3. So here what we simply do, we are going to subtract the powers. And when we subtract the powers, we shall have it as a raised to the power of 5 minus 3. And when we subtract, we get our answer as a raised to the power of 2, which can also be read as a square. Then when we look at our second example, we have a raised to the power of 7 being divided by a raised to the power of 2. So we are subtracting two numbers with the same base. What we are dividing two numbers with the same base. What do we do? Subtract the powers. It becomes a raised to the power of 7 minus what? Minus 2. We shall have our answer as a raised to the power 7 minus 2. We get our answer as 5. So our answer becomes a raised to the power of 5. So in general, this will now take us to our second law of indices. And our second law of indices says that if I have a raised to the power of m being divided by this side, you can easily see it very well. So we have a raised to the power of m being divided by a raised to the power of n. That we are dividing two numbers with the same base. What we do is subtract the powers, and that becomes a raised to the power of m minus n. So this takes us to our second law of indices. That when you are dividing two numbers with the same base, what you do, you simply subtract the powers. Learners, let me hope you are following what I am doing. So now we're going to look at our third law. So now what I'm going to do is to summarize the first two laws of indices. So we have looked at summary. We have looked at our first law of indices, which is a raised to the power of m times a raised to the power of n. That when you are multiplying two numbers with the same base, what you simply do is to add the powers. And that becomes a raised to the power of m plus n. Then our second law that we have looked at is a raised to the power of m being divided by a raised to the power of n. And when you are dividing two numbers with the same base, what you do, you simply subtract the powers. And this becomes a raised to the power of m minus n. So I want to thank you very much for attending my lesson. Hope you'll be able to follow it.